This project aims to enable end-to-end testing for YouTube uploads and associated media without using real Google APIs by utilizing an HTTPS proxy combined with mitmproxy. The motivation stems from the limitation that media uploads via the Google Apps library do not account for the root URL, causing standard mocks to fail and leading to either incomplete tests or unintended real API calls. Key takeaways include the fact that Google Apps ignores the root URL for media uploads, that HTTP mitmproxy is unusable in Node 20, and that using HTTPS proxy with mitmproxy effectively intercepts traffic from Google Apps. The installation steps involve using pnpm to install required packages, setting up mitmproxy, and creating a .mv.local file that includes necessary credentials. Notably, the mock server simulates API calls without needing real credentials. Usage modes include dev with real credentials and E2E tests that employ a complete mock setup. In dev mode, developers need a en local file with real credentials executed via pnpm dev. E2E tests can be run using pnpm test without real credentials, as Playwright automatically runs both the Next.js server and mitmproxy, intercepting all appropriate traffic. Technologies employed include Next.js for the framework, TypeScript for type safety, Playwright for testing, pnpm for package management, and mitmproxy for intercepting HTTPS traffic. Key concepts such as TLS for secure communication, SSL termination used in proxy contexts, and the role of the HTTPS proxy environment variable in directing traffic through mitmproxy are discussed to enhance understanding. The design process involved making strategic choices regarding the mocking approach and proxy tools for implementation. Context is provided on the importance of handling YouTube API requests correctly, ensuring tests don't reach real endpoints, while also referencing a related OpenAI API mock server. Various constraints are outlined, such as the need for OAuth for YouTube uploads, requirements for E2E testing with Playwright, and the limitations of using root URL, which fails for certain media uploads. Different design options are compared, with the third option, global network interception, proven to be the most viable for intercepting media uploads effectively without major code changes. The chosen design intercepts outbound requests globally using HTTPS proxy, ensuring all upload requests are properly handled through the local mock server while adhering to E2E test fidelity. Implementation options were discussed, concluding that mitmproxy is the preferred tool due to its stability and capacity for handling complex HTTPS traffic, ensuring robust interception for tests. The implementation of mitmproxy involves a Python add-on that intercepts requests to Google Apps, allowing for controlled mock responses and robust safety measures against unmatched requests. A diagram illustrates the architecture of the mock server and how it interacts with mitmproxy and real Google API endpoints. The code structure emphasizes key files necessary for the mock system, particularly the proxy add-on, Playwright configuration, and tests that ensure no real API calls are made. The proxy server add-on.py file implements logic to handle incoming requests, route them to mock responses, and enforce strict controls to block any unauthorized requests. The test proxy test TS ensures that any calls to real Google APIs return a 500 status code, indicating that the mock server successfully intercepted the requests. The playwright.config.ts file is set up to run the necessary servers and configure the environment to route all requests through the mitmproxy, ensuring proper mocking during tests. The demo section showcases screenshots of the application in different modes to illustrate its functionality and testing processes. Screenshots demonstrate the application's state before OAuth is applied during development. Screenshots show the user interface post-OAuth, indicating the successful authentication flow. Screenshots from the pnpm test illustrate the results of the mock server's successful interception of API calls. References guide readers to additional resources, such as related GitHub projects and relevant videos.